Hello everyone, happy to see you here, welcome back to my channel. Today we have a really interesting cubic equation b cubed plus b squared equal to 36. We need to solve this equation for b, so if you have your solution, your answer, you can also write it in the comments below and then we will check your answer, so it will be really interesting. So first of all, let's write the 36 on the left side, okay? This is our first step, so as a result, what do we have? We have b cubed plus b squared and minus 36 equal to 0. Right now, there are a lot of ways how can we solve this cubic equation, but I'm going to show you this one. I really like this method. First of all, this 36, because right here we have b cubed plus b squared, so we have a sum, cube and square. So right now, let's try to express this 36 as a sum of cube and square. There are a lot of ways how can we do this, because a lot of ways how can we express this 36, but of course, the best way to express this is to write this 36 as 27 plus 9, okay? And a lot of students might be asking, why 27 plus 9, maybe 18 plus 18, or 24 plus 12, but 27 also can be written as 3 cubed. So this is extremely helpful in our case, and 9 can be written as 3 square with the same base of 3. Yeah, so it's also really great to express this 36 in this way. So first of all, let's express this 36 as 27 plus 9. Okay, let's do it. So we have b cubed plus b squared, and in parentheses, instead of the 36, we can easily write 27 plus 9. So I'm going to solve this step by step because there are a lot of students here, so I'm just want to solve this step by step. 27 plus 9. Okay, the next step, real quick, we can easily open parentheses, but we need to change this sign. So we need to change this negative sign. So we have b cubed plus b squared minus 27 minus 9 equal to 0. And right now we need to go back right here because 27 can be written as 3 cubed and 9 can be written as 3 squared. So let's do this. So we have b cubed plus b squared minus, instead of 27 we write 3 cubed, and instead of 9 we write 3 squared. So everything is great. This is our first step. What we're going to do next, as I said before, it's also really great to have a cube and square, and a lot of students might be asking why. Right now, let's group this 3 cube from here with this b cube. Let's do this, and let's group this b square from here. Let's group with this 3 square from here. Okay, and what we have as a result? In first parenthesis right here on the left side, we will have b cube minus 3 cube. Yeah, so we have b cube minus 3 cubed. This is our first parenthesis. Then I think we have plus b squared. So, okay, we have plus b squared minus 3 squared. And right now, let's look at this question like from a different perspective, from another perspective. Because we have right here at this parenthesis, we have a difference of cubes. And of course, a lot of students might be asking, maybe I'll learn this formula at school, a cubed minus b cubed. So let's remember that. So we have a cubed minus b cubed. A cubed minus b cubed equal to a minus b right here, a minus b, and in another parenthesis we have a square plus ab and plus b square plus b square. Okay, this is our first formula. We remember it, we learned it, it's also really great. Another formula, it's much easier for us because we have b squared minus 3 squared. A lot of students, maybe everyone, knows this formula, b squared minus 3 squared. So this is our formula, a squared minus b squared. If we're talking about classic order, this is equal to a minus b, a plus b, a minus b, and times a plus b. Okay, really great. So right now, let's expand this expression in terms of difference of cubes. Let's expand this one in terms of difference of squares. So let's do it right now. First of all, I'm going to start it on the left side because we'll have a lot of space. So first of all, we have b minus 3. Yeah, b minus 3. First parenthesis. I applied this formula, okay? A cubed minus b cubed. I just want you to understand it. B cubed. And in another parenthesis, what do we have? B squared plus 3b and plus 9 and plus 9 in terms of this formula. In another parenthesis, we have b minus 3, b plus 3, b minus 3, b plus 3, b plus 3 equal to 0. And right now, forget a little bit about this, what we did before. Right now, let's look at this question from a different angle, because we have a lot of parentheses, and the main thing right here, we have the same expression, b minus 3, and we have b minus 3 right here. So basically, we can factor it. Okay, so let's do it right now. We can easily factor this b minus 3. So b minus 3, we can easily factor it, And in another parenthesis, we have a lot of things. We have this parenthesis plus this one. So we left with this expression and with this. Okay, so as a result, we have b squared plus 3b and plus 9, yeah, plus 3b plus 9. And we have plus b plus 3. b plus 3 equal to 0. Okay, but we need to close this parenthesis because I choose this option. I just want you to understand that we factor this b minus 3. Okay, right now let's simplify this expression. We can easily do that without any problems because we have all the time addition sign, and we can actually get rid of these parentheses at these places. So we have b minus 3, and in another parenthesis, so what do we have? We have b squared. We don't have squares, so we have only b squared, yeah, b squared, plus 3b plus b plus 4b, so plus 4b, and 9 plus 3 equal to 12, so plus 12, and equal to 0. Right now, a great moment because we have a product, and a product equal to 0 when the first parenthesis equal to 0 or the second parenthesis equal to 0. So let's start with the first one, so b minus 3 equal to 0, b minus 3 equal to 0, or the second parenthesis equal to 0, b squared, so the second branch, so b squared plus 4b and plus 12 is equal to 0. Okay, really great. And right now we can solve this question on the left side real quick, instantly, because b minus 3 equal to 0, so b first is equal to 3. So let's underline it. Okay, let's underline this answer. Right now let's solve another branch. Okay, we know first answer, it looks like a real number root. Yeah, we have 3. Right now let's solve another branch. B squared plus 4b plus 12 equal to 0. Every time I have this quadratic equation, this like from my perspective, this is also up to you how you prefer solving this type of question. I prefer start with discriminant with the basic method of coefficients. So we have a equal to 1, a equal to 1, b we have right here, but I hope you understand that this is our second coefficient. This is our b equal to 4 and c equal to 12. Okay, we know everything. Right now let's find real quick our discriminant. So d equal to all known formula, b squared minus 4ac. Right now let's find our discriminant. So b squared equal to 4 square, yeah, 4 square minus 4 times a times 1 and times c times 12 equal to 4 square equal to 16, yeah, minus 4 times 12 equal to 48. And if we subtract to it, we have minus 32. And a lot of students might be thinking, okay, we don't have right here roots. But yes, we don't have right here real number root, but we have two complex roots. So when discriminant is less than 0, so it implies that right here we have two complex roots. Okay, two complex roots. Okay, really great. Right now let's find this root. So a second and a third equal to minus b plus minus square root of discriminant and all over 2a. We know everything, so minus b. We have minus 4 plus minus square root of discriminant square root of minus 32 and all over 2 times a times 1. Right now we can easily expand it minus 32, so we can express it as a product. We can write it as 16 times 2 times minus 1. And let's do this. It helps us to simplify this expression. So minus 4 plus minus square root of 16 times 2 and times minus 1. Okay, this is the same thing, but from another perspective, we need to learn or remember a really great property, because when we have square root of a times b, this is equal to square root of a times square root of b. And right now let's split this product. We have 3 expressions, so we can also add right here c, a, b, c, d. Doesn't matter how many expressions right here you will have, but in the same way, in our question we have 3, so we can easily split it like minus 4 plus minus square root of 16 times square root of 2 times square root of minus 1. Yeah, all over 2. Okay, right now square root of 16 equal to 4. This is our imaginary unit. This is our I. So we will have our answer, our complex root. So minus 4 plus minus square root of 16 equal to 4 times square root of 2 and times square root of minus 1 equal to square root of minus 1 equal to I times I. all over 2. Of course, our last step, we can divide our left side and right side by 2. Okay, so as a result, we have minus 4 divided by 2 plus minus 4 square root of 2 times I divided by 2. Okay, minus 4 times 2 equal to minus 2 plus minus 2 square root of 2 times I. So these are our two complex roots. So right here we can let's write our final answer. Let's group all of these roots together. So we have our answer on the right side. So b first equal to 3. And right here, of course, b, I just write a, but this is our b. Okay, so b second equal to minus 2 plus 2 square root of 2 times I, and the third root b3 equal to minus 2 with the minus sign, minus 2 square root of 2 times I. Okay, really great, really great. These are our two complex root. Okay, two complex roots, and of course this one is a real number root. So this is our answer to this question. Of course, right here b, I just forget a little bit because of these coefficients. Coefficients are the same. So right here we have b. I hope you understand it. So real number root to complex root, and a lot of students might be thinking, because there are a lot of questions where you don't actually sure how many roots you can get from here. Okay, because when we have b cubed plus b squared equal to 36, and right now I'm going to give you a really interesting and quick hint, because there is a formula, not like formula, a theorem, which is called like fundamental theorem of algebra. It helps us to find out how many roots we can find from equation, because b cubed plus b squared equal to 36. What we can do at first, we need to find out where do we have this, what is the highest power. In our question, of course, 3 is the highest power. 2 is not the highest, but 3 is the highest. So 3 means the number of roots. Because of this 3, we can easily say, okay, I have 3 roots in total. I don't know how many real number roots are, how many complex roots. I have 3 roots in total. 2 complex, 1 real, 2 real, 1 complex, doesn't matter, but this theorem helps us to find out how many roots we will have in this question. Okay, 3, it means 3 roots in total. Okay, so it helps us to prove. Maybe you sit in your exam and you have a equation like b to the power 5 plus b to the power 7 equal to, for example, equal to 10, and you might be thinking, okay, I find 7 roots, and you might be thinking, okay, maybe I have 8 roots, but according to a fundamental theorem of algebra, you can easily do this instantly. For example, you sit in your exam, and the first thing you pay attention to, just see this 7, and you might be thinking, okay, 7, it means I have 7 roots in total. 5 real, 2 complex, 3 real, 4 complex, a lot of combination, but it helps us to find out what is the amount of roots. I hope you understand it. And finally, let's check our b first equal to 3. This is our final step to this question. Let's check it right here at this place. So let's check. So b first equal to 3. We have b cubed plus b squared equal to 36. So we have b cubed 3 cubed plus b squared 3 squared equal to 36, and everything is great because 27 plus 9 equal to 36. And a lot of students might be asking, okay, right here I can solve this question instantly, because sometimes happen, a lot of students might be thinking, might be solving this question by inspection. They might be thinking, okay, 1 is not good, 2 is not good, 3, yes, 3 is great, so my answer is 3. But you forget about the second part, our complex part. Right here we exactly have it, and with inspection method you can't find this complex root. You can solve this question for a complex root, and it's extremely important nowadays, because if you forget about this part, you can easily solve this question, of course, with the 2 or 3 lines, but this is not a good solution for you, and of course for your teacher, because this is a wrong solution, and of course a correct answer, because 3 is a correct answer, but you forget about complex. So this is not a full solution. Full solution is right here. You just do this step by step. Don't be lazy. All you need, just learn these 2 formulas, which is extremely helpful. Where do we have it? Yeah, we have it right here. So just learn these 2 formulas. Try to expand something. Try to add. Try to subtract. And if you do this, you can easily be successful at math, because every time you sit in, for example, at home and try to learn something, try to do it on your own. This is the main thing. It helps you to learn math. And in this question, you can easily solve this with these two formulas. Nothing hard, just two formulas and basic calculation, basic mathematics. Just look at this, solution, express this like that. Two formulas and we factor it. And the quadratic equation, we don't have cubic equation, force power equation, we have basic quadratic equation, you know. So yeah, this is my thought about this question, and this is my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of videos on my YouTube channel. There's like a great community here, a lot of teachers, students in the comment section, so they will help you 100% with their questions. So I really want to say thank you for everyone who are with me and who watch my videos and support me. With a like, with the comments, it's also really appreciated, but this is up to you. If I deserve it, of course, it's also really appreciated, yeah? So wish you all the best in your life, take care of yourself, and have a great day. See you in the next videos.